electromagnetic wave. It consists of varying electric field and varying magnetic field which are perpendicular to each other as shown in figure 1. If the light has a single wavelength or frequency, it is known as monochromatic light. We know that two or more light waves travel in space at the same time. Sometimes these two wave motion combine and some physical effect take place. Interference is one such physical effect. Interference is defined as the effect of interaction between two or more waves which superpose or overlap at a point and at a particular time from the sources. For light, the interference is occur when two light waves meet at a point, producing bright or dark region in accordance to the principle of superposition. Principle of superposition states that the resultant displacement at any point is the vector sum of the displacement due to the two light waves. When a crest of wave 1 meets with a crest of wave 2, or when a trough of wave 1 meets a trough of wave 2, the resultant displacement will be maximum, or it is called constructive interference. Constructive interference is defined as a reinforcement of amplitude of light wave that will produce a bright fringe. When a crest of wave 1 meets with a trough of wave 2 or vice versa, the resultant displacement will be minimum, or it is called destructive interference. Destructive interference is defined as a total cancellation of amplitude of light waves that will produce a dark fringe. On this topic, there is an important term that students must know, that is coherence. Coherence means the source of wave must have the same wavelength or frequency, or also known as monochromatic light, and the sources of wave must have a constant phase difference between them. As example, look at figure 2. Wave of source 1 and source 2 has a single frequency. Both waves also has fixed phase difference between them. Thus, both waves are coherent. Look at figure 3. Source 3 and 4 do not have fixed relationship of phase difference between them. Thus, waves for source 3 and 4 are non-coherent. There are two types of coherent sources, that is, in phase and antiphase. For in phase, two or more wave sources start at same phase. Look at example 1. Wave of source 1 and source 2 start at 0 degree phase angle. Thus, both waves are in phase. For antiphase, two or more wave sources start with phase difference of pi radian or 180 degree or lambda over 2. Look at example 2. Wave of source 3 and source 4 started at different phase angle. Wave from source 3 start at 0 degree phase angle, while wave from source 4 start at 180 degree phase angle. Thus, both waves are antiphase. Condition for interference of light. First point, the two sources of light must be coherent. Second, the light waves that are interfering must have the same or approximately of amplitude to obtain total cancellation at minimum or to obtain a good contrast at maximum. Third point, the distance between the coherent sources should be as small as possible, comparable to the light wavelength. Path difference is defined as the difference in distance traveled by two light waves meeting at a particular point. Refer to figure 4. The path difference is distance from S1 to point P minus distance from S2 to point P. That is equal to x1 minus x2. x1 is equal to (5.5) lambda. x2 is equal to 6.5 lambda. Thus, the path difference for figure 4 is 1 lambda or 1 wavelength. Path difference also has direct equivalent to phase difference. Mathematically, delta L equal to delta V. One lambda path difference is equivalent to 2 pi radian or 360 degree phase difference. Condition for constructive and destructive interference. If two coherent sources in phase, for constructive interference or bright fringe to occur, the path difference between two coherent waves must be equal to 0, lambda, 2 lambda, 3 lambda, 4 lambda, and so on. Thus, the formula of path difference will be delta L equal to m lambda, where m is the order, that is 0, plus minus 1, plus minus 2, and so on. For in-phase sources destructive interference to occur, the path difference between two coherent waves must be equal to half lambda, 1.5 lambda, 2.5 lambda, 3.5 lambda, and so on. Thus, the formula of path difference will be equal to delta L equal to m plus half lambda, where m is the order, that is 0, plus minus 1, plus minus 2, and so on. If two coherent sources are antiphase, the path difference of constructive interference will follow the formula of path difference for destructive interference in phase. For dark fringe antiphase source, the path difference formula will follow the constructive in phase. Exercise 1. Two light sources are said to be coherent if they C. I get it. B. Exercise 2. Two beams of coherent light travel different paths, arriving at point P as shown in figure 5. If the maximum constructive interference is to occur at point P, the two beams must A. C. For more understanding, please check your previous knowledge about light wave and interference. Do not forget to check more information on the link given. Thank you for watching.